let's have a look at some of the common heat measurements that we make in thermochemistry. Our first one is our delta HF, or what we call our heat of fusion. So this is a subscript F. And the heat of fusion is the change in enthalpy required or calculated when we go from heating a given quantity of a substance that's in a solid form to a liquid form. So we're talking about the phase change between solid to liquid. As the substance absorbs heat, it goes from that solid state, and we could give an example of ice to water. It would take a certain amount of heat for a given quantity of water to do that. Our delta HV is what we know as our heat of vaporization. And this is an extension of the first one, a change in enthalpy when we heat a given quantity of a substance from a liquid to a gas. So we're talking about this phase change this time. So if we go from liquid water to gaseous water, it's the amount of heat absorbed by that given quantity of water to go from liquid to gas. Our next one is known as the heat of solution, and that's delta H with a subscript S. And this is the change in enthalpy for a substance when we dissolve it in a solution, into a solvent. Most commonly we use water, but we could use other solvents as well. So the heat of solution is the heat absorbed or given out when that substance dissolves in water. The next one down, we've got our delta H, and we put an Rxn here, and that's our heat of reaction. So that's the change in enthalpy for a given reaction. And remember that we can have exothermic and endothermic reactions, and our sign for that value will denote whether we have exothermic or endothermic. We also have two other reasonably common ones, but not as common as these four. We've got a heat of combustion, which I always put in as a subcategory of our heat of reaction. But you may be asked to calculate the heat of combustion, in which case it's a reaction that's combining with oxygen. And most commonly we see our carbon-based compounds, so methane, ethane, our organic molecules. And finally we have what's called heat of atomization, and that's the heat required to convert any substance to its atomic form. So a nice example might be oxygen as a diatomic gas. How much heat is required to convert this to oxygen atoms? So there are our common measurements that we make for heats.